Hello everyone. Today I want to talk to you about Cartesian coordinate system and the window command. The window command right now, I always put 0, 0 in the bottom left corner of my screen so that y increases as it goes up and x increases as it goes to the right. And that's what the window command does. If I don't use the window command, let me comment this out, save it and run, and let's see what this does. 0, 0 is going to be in the top left corner. See, I have drawn a circle right here. See that right there? I've drawn a circle at 0, 0, and it's in the top left corner. If I uncomment this and save and run, now 0, 0 is going to be in the bottom left corner. So you guys have been familiar with this for a while. But here is a Cartesian coordinate system, has an x and a y axis, and I want that to be in the middle of the screen. How do I get that to show up in the middle of the screen? Well, what you do with the window command is you just say, I want this to go from minus 200, and this one right here, minus 200, and instead of 399, 199. So let's see what that does. Okay, so now 0, 0 is in the middle. See, I still got my circle being drawn at 0, 0, so it's drawn it. Now, it's if I draw another circle at 0, 0, circle 0, 0, and make this one a radius of 20, and the color 14, yellow, save and run. You can see there's my circle, yellow circle drawn at 0, 0, but it's actually in the middle of the screen, and that's because I shifted the window starting negative 200 all the way to 200. So when I look at this, over here is negative 200, over here is 199. And of course down here on the bottom is negative 200, and up here is 199. 0, 0 is right in the middle. Okay, let me pause for a second. So now you know how that works. Now I want to talk to you guys about plotting an ellipse and plotting a parallel inset and outset, what I call offsets. And these are for the tool bit path. So let me just copy these. I always use pi and convert back and forth between radians and degrees. Let me just copy that and paste it up there. Paste all my variables. So instead of drawing a circle, okay, I don't need the yellow circle. And I'm going to make this circle 100. And what I'm going to do is, okay, let me also add some variables up here for x and y, dimension as double x and y. So you know that using the cosine function, I can say x equals the cosine of, let's say 45 degrees. 45 degrees times, and you know the cosine function in freeBASIC, it uses radians. Let's see, where is it at? It says the argument number is measured in radians, not degrees. Okay, so that's why you have to convert degrees to radians, and the way that you do that is you just multiply the degrees times times pi divided by 180, which is what this variable is right here, times degrees to radians and then times the radius. I want the radius to be 100 times 100. So I can put up another variable up there called radius. I could just say radius here, and I can put it right here. Radius equals 100. And that's what the value of x is going to be equal. Y is going to equal the sine, y equals the sine of 45 degrees times degrees to radians times radius. Oh yeah, because that was also 100 before. Okay. And put it right here. Copy, paste. And so that's what the value of x and y is going to equal, which should be in the upper, at 45 degrees, it should be in the upper left corner of the circle. I'm sorry, the upper right corner of the circle. And if I actually draw a circle at x, x comma y, and I'll make the radius times 20, and save and run. You can see that it's drawn a circle in the upper right quadrant of the Cartesian coordinate system on the circle itself. That's a point on the circle. Let me just make that radius a little bit smaller. We'll say radius of 4, and we'll make it the color 14 yellow. Save, run. So x and y equals, see, there it is right there. X and y equals this point right here. So this is 10, 20, 30, 40, 50, 60, 70, and it's 70 over on the x and 70 up on the y. And in fact, I can print the value of x and y. Let me see here. X equals print y equals y. Save and run. And you can see the value of x is 70.7, the value of y is 70.7. So 70 over and 70 up. Now if I wanted to plot, if I wanted to put a whole bunch of circles all the way around this big circle, I could do it inside of a loop. I could go like 4 degrees as integer equals 0 to 360 step 15. And instead of I'll just start at 15 degrees because this is going to end up at 0 anyway. So I'll just say 15 to 360 step 15, and then I will tab this over. Next, and let's just get rid of this right here, and let's see how that looks. So, oh, sorry, I should have put in here the variable degrees. Copy, paste, and run. And you can see it puts these little yellow circles every 15 degrees on the circumference of this larger circle with a radius of 100. Okay. If I wanted to plot an ellipse, ellipses have two radius. They have a major radius and a minor radius. So I can say major radius, and minor radius. And I can say major radius equals 100, minor radius equals 50. And instead of radius here, I could say major radius, and minor radius. Oops. Okay, let's save and run. Alright, so you can see that it's now plotted in an ellipse with a major radius of 100 and a minor radius of 50. And my goal is to try to get an offset off of these. Okay, hold on a second, let me pause for a minute. Okay, hold on a second here.